define internal energy. So internal energy means the total random kinetic energy. So total random kinetic energy plus total potential energy. And this is a definition of energy, of internal energy. So internal energy refers to the sum of total random energy and total potential energy. 0.46 mole of a ideal monoatomic gas is trapped in a cylinder. The gas has a volume of 21 meter cubic and a pressure of 1.6 Pa. State how the internal energy of the ideal gas differ from that of the real gas. So for this one, you just need to mention one of the assumptions about ideal gas, and one assumption is that intermolecular forces of a ideal gas is 0. So the force between molecules are negligible, and this is one assumption about ideal gas. Determine in Kelvin the temperature of the gas in the cylinder. So let's go back to here. So we know that it has a volume of 21 cubic meter, and we also know their pressure. We know the number of moles, so we can use ideal gas equation. So pressure multiplied by volume is equal to number of mole multiplied by R constant multiplied by temperature. So temperature is gonna be equal to pressure multiplied by volume divided by N multiplied by R. This is gonna be equal to, so since here is 1.4 Pa, you need to convert that to kilopa. So 1.4 multiplied by 10 with a power of -3 multiplied by volume, which is 21, and you need to convert that to decimeter. So we are gonna convert that to decimeter. So let me just rewrite the whole thing. So from here we know that temperature is equal to PV divided by NR, which is equal to 1.4 multiplied by 10 with a power of -3 multiplied by volume, and convert that to decimeter, divided by number of mole, which is 0.46 multiplied by R constant, which is equal to 8.31, and this is gonna be equal to 7.7 with a unit of Kelvin. The kinetic theory of the ideal gases is one example of scientific model. Identify one reason why scientists find such model useful. So the biggest reason why is because it allows scientists to study real gas, and that's the reason why we have the assumption of ideal gases.